It's my first time in Norway, so I'm having a fun time. And I'm going to talk to you about simplicity, which is an insanely overloaded word, right? Everybody says your code should be simple. Everyone has a different idea of what they mean by simple. And I want to clarify what I mean by simple, and especially what I don't mean by simple. So I teach C++ in a lot of different contexts, and I teach little pieces of C++ like one-on-one to someone that doesn't know something, and I'm like, let me show you. And when you're doing that kind of teaching, you very deliberately use sort of a beginner simplicity, right? So we say, I'm not going to include any error checking or any error handling in this example. I'm going to show you how to, I don't know, figure out if numbers are prime or whatever the example is, but I'm going to just assume that I got good input, and especially that I didn't get malicious input, right? Because I'm there to teach somebody like what the modulo operator is, and I don't really have a lot of time for like, sometimes there are bad people on the internet who want to break your computer. If there's a two ways to do something, like here's what you do if the target element is after the source element in the collection, blah, blah, it won't show the other direction. Those are kinds of keeping it simple for beginners that we all do when we're teaching. And we do this for a very good reason. We're trying to focus on, what's a vector, or what's the modulo operator, or what is RAII, or whatever we're trying to teach. And the person who's trying to learn is only trying to learn one thing. So they don't need their head filled up with, the realities of the Canadian retail sales tax system, or the fact that there are bad people on the internet who want to hurt your computer. Right? We're trying to lower their cognitive burden. And we also have a distinct case of the medium being the message, which is that we are also trying to fit our slide on one screen. Okay? So I can't show you forward and backwards because then the font would be too small. And that's a real thing. And probably most importantly, when we make up examples of like, here's how to do something with a vector, we have zero context. It's not a real problem. We don't actually have a bunch of people who need their paychecks or whatever. We just have a vector. So we give it the brilliant name of V because names actually come from context, and we don't have any because it's just a sample. Okay, that's how we start at the very, very beginning as beginners. But real life is not like that. Real life is complicated. In real life, you have to check your input, both that it's legitimate and that it's non-malicious. You have to handle errors. You have to live in a world where people want to hurt your computer. And you have to do both directions. And this makes the code get bigger. People start adding ifs beforehand to check this, that, and the other. And they start adding loops, and they start adding this, and they start adding that. And that naturally means that that code is more complicated than the beginner Play-Doh version that you started with. I don't have a problem with that. But what I've noticed is what happens to us. As we go through our growth as programmers, we say, well, simple is for beginners. Real life is complicated. So, sure, this code is, hard to write, so it's hard to read. And we get kind of proud of producing a thing like this. I don't know how many months of work this was for somebody to carve out of wood. But it's in a glass case. And one of the reasons it's in a glass case, right, is it's super fragile, right? You don't want to break off one of those little figures that someone took so long carving. If it was easy, we say anyone could do it. I want to advocate today for a kind of simplicity that has nothing to do with leaving out vital error checking or only handling forward or whatever. I'm defining simple code as being code that is expressive. When you read it, you know what it does. It's readable. You read it, you understand it, and it doesn't surprise you. I mean, we've all read code where you're like, what? Oh, right? Fun as that oh moment is, it's actually more fun not to need it. It's more fun to just get it from the very beginning. Code that explains itself has no opaque aspect at all. That's what I'm kind of going for. And I believe that code can be reassuring, right? It can tell you a story. First we open this, then we initialize that. There's a loop in which we process everything, we clean up. And those are the words on the screen, right? You see words like open and clean up and, allocate or whatever it is you're trying to do. That code can tell you a story and lead you on a story through what it is that it does. So this isn't about simpler means that it's shorter. Sometimes simpler code is longer. This isn't about simpler means that it's made out of smaller things. I mean, we could all just write in ones and zeros if we wanted to make it out of smaller things, right? You know, a ranged for is more expressive than a random old school for loop, specifically because it says, I'm touching every element in the collection exactly once. Doesn't take long to read an ordinary loop to know that, but it doesn't take any time to read a ranged for to know that, because that's what a ranged for does for a living. When you call something from the algorithm header, some standard library function like sort, that's simpler than a raw loop because the letters S-O-R-T are a super powerful clue as to what the function's going to do, compared to reading the loop and going, if it's less, it moves it earlier. Oh, I get it, it's sorting it. 10 simple lines anyone can follow, simpler than one line that relies on a trick that people may or may not know. I want to convince you that simpler is better, but in addition to defining simpler, you gotta define better. It could mean that you can produce more lines of code per day, week, month, year. It could mean that there are less bugs in it, that it's higher performant, that it's more readable, or that it's more modifiable, which are different. Or, and I think a lot of people leave this last bullet out, that it's more fun. Hands up if you think it's okay for work to be fun. Okay, just checking. Because I think work should be fun. I don't like doing things I don't enjoy. And some of the code I have to read, I don't enjoy. And some of the code, when I read it over again, I'm like, man, this was good. I like this. You know, and why not? We should write that. So let's start with the bad news. I don't think it's going to be faster to write simpler code. This is a much simpler piece of wood carving, but I'm sure there was still an awful lot of hours went into it, in the designing and in the executing, right? Polishing your code to be complete and yet obvious is more work than slamming something together that probably has enough ifs in it, right? There's this quote, I'm sorry that this letter is so long, but I didn't have time to write you a short one. When I was prepping the talk, I decided to see who wrote this. Who should I cite? Well, Americans mostly feel it was Mark Twain, and Europeans seem to feel it was either Blaise Pascal or Samuel Johnson. So as a Canadian, I think I should say it was Margaret Atwood. I think that's my rule. Whoever it was, they didn't have time to write a shorter letter, and that's what I want you to do, is to develop these new habits to write that shorter letter. So you have to look at code differently, and you have to re-look at code. So I wrote it, and it works, but is it what I want to leave? Am I done? Or is there something I can do? Something I can refactor, something I can rename, something I can reorganize, so that this code tells a story as well as just plain working. The good news is, yes, I believe simpler code is more correct. I get brought in when people have code that they have painstakingly acquired over decades, and they no longer really own it because they cannot change it, because the last person who understood it left. And usually they tell me their number one pain point is they have something very specific they need to do to this code, and they need me to help them do it. But, oh yeah, by the way, we do have a lot of intermittent bugs that none of us understand. When I make that code simpler, magically, the bugs go away. RAII, that is simpler. I came into something which had, I printed it out, and I don't normally print out code, but it was 7 pages for a loop. It was the main engine loop of the app. And there were, I have miraculously forgotten exactly how many catch statements there were. That's good, that means I'm growing. Let's say 7, okay? It was more than 3, less than 100. And these catch statements had go-tos in them, and there were several different labels that were gone to. And it was a series of whiles that were all while true. So the only way to get out was through an exception being thrown. And then depending on what kind of exception it was, you either went to go to retry from the catch block or go to exit from the catch block. And all of the catch blocks consisted of if some Boolean or another has been set, and then it would do a bunch of cleaning up. So it was like, if I got the mutex, clean up the mutex. If I opened a file, close the file. If I this, if I that. And I taught these people RAII. and they moved all their cleanup into destructors. And the catch blocks all went away. They didn't need them. So that was miracle number one. Miracle number two was that the while statements actually got to have proper conditions in them, like while user has not pressed cancel, right? And while still connected. But the beautiful miracle was when they told me later about the intermittent bug that was now gone. Because sometimes, under certain combinations, something didn't get cleaned up and like the file got left open or whatever. Because they were hand rolling all their cleanup. And they messed up. In one of the catch blocks, you should also close the file, and they didn't. So you got code that was readable, understandable, maintainable, and more correct. And that happens to me every time I touch a code base. Okay? Because doing it all yourself by hand in the complicated way gives you places to forget. Relying on structural support, like destructors going off, you cannot forget, therefore it will be more correct. So it's not like you have to trade off, like, well, sure, I'd like to be able to read and understand this code, but it's kind of important that it works. No. They go together. When you can read and understand it, it's also more likely to completely work. The other thing that happens over decades is that code gets inconsistent. There's 50 places you're supposed to make a change, and you make it in 48 of them. That works for any two values of n. There could be 2 places you're supposed to make a change, and you make it in 1 of them. We're just humans, and we forget things. So if you have one function that takes 3 parameters, but the 3rd parameter has a default value, that's more consistent than if you have 2 functions, one that takes 2 and one that takes 3, because then in the future, you got to remember to change both functions. If you have a function at all, you are ahead over the copy-paste edit cycle of the world. I was doing code review on something, and I said to someone, this is a really strange variable name. Let me see if I can sanitize it. You're calling it candidate name, but it's about an employee, not a candidate. And they said, oh yeah, I don't want to change it though, because I copied it from the candidate code and I understand it with that name. So I don't want to change it to employee here, because then I won't remember what it does. Okay. So maybe writing a function, right, and being able to pass different parameters into that function is better than copying and pasting the 50 lines of code and changing some of the hard code stuff on the 50 lines of code. And again, in the future, you only have to change one place, so it's simpler. If you have a number of functions that are very similar, maybe take a big breath and write a template. Again, now in the future, you only have to change the template rather than successfully changing 9 of the 10 functions. When I move complexity into abstractions, sometimes that's all I'm doing is moving it. Okay? So if you call sort instead of writing your own loop to sort, you haven't made sort faster unless your own loop was like really bad, like you did a bubble sort or something. You've just moved it, and that has its own value. But sometimes it disappears. And I find that especially true of cleanup. The whole do I have a valid object that I now need to clean up problem becomes the compiler's problem, not yours, and it goes away. It's completely invisible. So very often as you make your code simpler and more obvious, you actually have a net gain forever. It's not just that you moved it, the complexity went away. Another thing I advocate in making code simpler is to call other people's code. This is a challenge for most of us because we don't like other people's code because it's not our code. I get that, really do. But if you can bring yourself to use other people's code, not only has it been tested, but they have thought of all the weirdo edge cases about people copying things to themselves and all of that stuff that we forget to do, or that was left out for simplicity back when we were in our Play-Doh phase and nobody told us. You know, I see an awful lot of operator equals that aren't checking for self-assignments and gleefully destruct themselves and then have nothing to reconstruct themselves from, that kind of thing. In that same spirit, whenever you can use a library function, someone's thought of that, and you don't have to think of that. Will your code be faster? I wish I could say yes, but probably not. Right, take a look at these 2 ranged 4s. Assuming that people is a collection of person objects and that a person object is of a reasonable size, the first one, right, is going to be making a new temporary p for each time through. With the reference, we're going to spare a copy. You can't get faster code from the faster code fairy by wishing, right? You have to know something about the language. Now, it's not always as simple as I want to avoid a copy. It may actually be as simple as like, oh, I'd like to use copy elision here and count on the return value optimization because, nothing at all is even faster than a move. But you have to know your language to get absolutely peak performance. And the good news is you don't always have to live like that, okay? Don't choose simplicity over performance if the performance hit is real and exists. But that's the if. That's the big if. Compilers and optimizers are better than you. And if you don't believe me, you can use Compiler Explorer and see for yourself, right? Optimizers do some very, very cool things. And Matt Gobbolt had a talk at CPPCon last year where he kept trying to write efficient code and getting exactly the same assembly, right? It didn't matter. No matter how much he tried to hand unroll things, the optimizer was miles ahead of him. So if you can write code that people can understand, and the optimizer can make it fast, that's better than you writing code that no one can understand and that's probably correct, but ends up no faster because the optimizer can't do those things to it, okay? So if you haven't measured, you don't know anything. Especially true now in our universe. We may have all developed some intuition over the past little while, but a lot of that intuition has been completely upended. They say, if you want high performance, pass by value. And people are going, wait, what? No. So we have new sets of intuitions. If you're not measuring, you don't know. It also may not matter. I got in a big argument with someone about using string stream, because it's so slow, to parse command line parameters on a server that starts every few weeks. I'd rather we got the command line parameters correctly parsed. And again, library code, other people's code, could be faster than what you would write, especially if the implementer has some inside knowledge, right, about the structures they're working on. The first thing I do after I write code is I read it. The second thing I do after I write code and I read it is I start to debug it. If you have a habit of writing in a clear and open and transparent way, you get to read nicer code the minute you lift your fingers up off the keyboard, right? That's a pleasantness compared to reading yucky code. Simple as that. You may also spend less time debugging it. That's a pleasantness for you right now. The rest of the goodness is about, gift to the future. But remember that the future may be yourself. So it's a gift to you tomorrow or a gift to you in a year. Or a gift to you in 10 years when you don't want the phone call or the email from the person who's maintaining it now and is asking you a few quick things. The less it surprises anybody, the easier it is to maintain, and the more fun it is to work with. And this is really a hard lesson for us all, but other people's code is beautiful. I don't just mean, yeah, because you didn't have to write it, so that makes up for its other people's-ness. Or it's already tested, so that compensates for the whole not by me. I just actually mean this as a fact. Like, I write code that's beautiful, and hands up if you've ever written code that's beautiful. How can that be when you're not me? And I'm not you? My canoe is beautiful, and it's simple in the way that I'm talking about here. Right? It literally has no moving parts. It is incredibly expressive of what it does, which it floats in very little water and takes me to places I couldn't otherwise go. And my husband and I made it out of pieces of wood and fiberglass cloth and resin. A C++ programmer said to me, "Did you cut the wood into the strips?" No. Also did not cut down the tree or plant the tree. Okay, let other people's code be your pieces of wood. You can build gorgeous canoes out of them. So I told you I come in and I try to make people's code better, which usually makes people's teams better. It's actually how I do it. I do change code, but I also try to change people. And I've learned that if you want what I'm going to call a polished simplicity or a complete simplicity, which is not blobs of Play-Doh, right? It's really hard work. It's easy to leave out the error checking. It's hard to make sure that even if someone forgets to call cleanup, things will get cleaned up. Okay, that one's not really hard. You can have that as a free consultant tip. Use RAII. But in general, writing code that's complete, that takes care of everything, yet is not obscuring what it does, is really open about what it does, and really it leads people through how it works, is hard. You have to know what you're working with. You have to know the language, which is a moving target. So the things that you might have memorized in 1998 or 2005 are not necessarily the current things. You have to know the library. I was in the same room for the previous session. I think a lot of you were too. So you know, what's optional? How does it work? What's variant? What's that for? You have to know, because these things may be elegant and simple solutions of ways of representing something that's kind of gross in your code right now. I especially like optional and variant for the way to get you away from pointers, right? But why would you want to get away from pointers? So you have to know about things like how CPUs have changed in the last, say, 3 decades. You also have to know the C++ way of doing things. As someone who's had to maintain, Fortran compiled with the C++ compiler, basically, things that are written in a C++ way communicate to other C++ developers. You need to know what those idioms are. So this is a totally different kind of simplicity, right? This isn't, I left that out to keep it simple. This is, I left nothing out, and yet what is here is very, very simple, like this little polished metal ball. Doesn't have any pits in the surface or cracks or fissures or weirdnesses, and that was hard work compared to it just being a rough blob of metal. People say, okay, so give me the rules. Well, there are no simple rules to write simple code, which is just how it is, but I will give you some things that help. And I'll start easy and work my way up. The easiest thing to do is to be able to recognize simple. So I think people are familiar with Lego. This actually isn't Lego. This is Lego Duplo Interop, right? And that's important. That's an important part of the design of Lego and Duplo, that they have their simple but very consistent simplicity throughout. So if you know what makes your code simple, you try to write it the simplest way at that moment when your fingers are paused over the keyboard. But when it turns into like this big cascade of ifs and twists and things calling each other and whatever, back up and say, what can I do to make this simpler? If I have a pattern of functions, member functions in a class that are constantly checking some particular member variable, maybe switching on it, and then doing really entirely different things, maybe this is actually some kind of a polymorphic hierarchy, right? Rather than saying if type equals regular and if type equals special, maybe I should have, classes that implement the function entirely differently for regulars and for specials. Maybe that would make things simpler for other people to understand. Do something to make it simpler. And take away those opportunities to be inconsistent where you can. Big thing here is giving good names. They say that a consultant is someone who will borrow your watch to tell you what time it is. My theory is if you're walking around with a watch on and you don't know what time it is, you need my help. This is the sort of code I see in the world. Maybe not quite this short, but this concept. You have a comment telling you what's going on, immediately followed by a variable with a terrible name. I for integer. And then you have a loop. Well, let's start with this. Right, there's the name in the comment already. I can't tell you, it's kind of embarrassing sometimes to charge a lot of money to say things like, well, it says annual revenue right here in the comment. How about we call the variable annual revenue and then it'll be more obvious? And everyone goes like, wow, she's great. But I can do better. I can also get rid of the loop because we have accumulate. I want accumulate to be an algorithm so bad, but it's actually technically in numeric. But it's like emotionally it's in algorithm, right? So accumulate adds up all the things in the, not necessarily in the whole collection, but I'm passing begin and end. So now, assuming that the people in your team either recognize accumulate or are able to go to cppreference.com and look it up, now we don't need the comment at all. The code just tells you what it does. And that's simpler. In this case, it happens to be shorter, but that's really not the point. especially code that was originally in C or that was written by humans who were originally in C, you get into the top of some, 5,000 line function, and the first 2 or 3 screens is just declaring things. And it's like double D1, D2, D3, D4, D5. Maybe before there was autocomplete, it mattered that your variable names were short. Now it does not. Using long variable names is free. Call your variables annual revenue, right? Quarterly increase, new employee, whatever. In fact, refactoring into functions, the most important reason, I think, for calling a function is because the function has a name. And a name from algorithm is a known thing. If I see accumulate, if I see sort, if I see find if, I don't have to go read that function to find out what it does. I can look it up on CPP reference, or I can just know what it does, and I'm done. That means that people can read the story of the code without having to go in and see what it does. Constants can get names in the form of putting them in enums or by using const or const expr. Giving things names like maximum daily limit, it's a good thing to do. Especially, I think I have to blame the Babylonians for this, but I don't care who it is. We have 60 seconds in a minute and 60 minutes in an hour, and when I just see 60 in the code, I don't know what you're doing. Right? But if you call it seconds per hour and minutes, seconds per minute and minutes per hour, even though they both have the same numerical value, I know what's happening. Of course, you probably just use std chrono. That's not a game. And I want your functions to be short, not so you can print them. We don't print anymore, right? Not so they can fit on one screen and be seen all at once. Don't care about that either. The reason I want your function to be short is so they can have one name, so they do one thing. A 5,000 line function doesn't do one thing. It's possible that you have 2 functions lurking together. It's possible you have one function that needs to be split up into the first part and the second part or what have you. And functions you didn't write are, again, emotionally short. And I think I've done variants of this talk before, and I always have a library maintainer in the front row, and I say things like, I don't know how long standard accumulate is, and Marshall tells me. I think I'm maintainer free today. I still don't know how many lines long accumulate is, and I don't care, right? Because it's not my problem. And in big software code bases, there's other functions like that that are part of the system. They're not part of the standard library, but again, you don't care. I work on a 20-plus-year-old product that has a function called update database that reads some files off the hard drive and loads them into this giant array of doubles, and everything else works from the giant array of doubles. And there are certain places where, like some magic talisman, you say update database before you do anything to make sure that the doubles are up to date. No one ever has to go in and step through it and read it and know how it works and whatever. It was written in a 1402 and hasn't changed since. So nobody cares about the length of that function. It's fine. Things that change a lot, those are the ones where keep them short so that people can read them and know what they do. Parameter lists. Functions that take 27 parameters are hard to get right in a lot of different ways, especially when they're all the same type. There's 11 ints, and then there's a handful of bools, and then there's 3 doubles, and nobody can remember what order they are. And here, it's about abstraction. Why pass 4 integers when you could pass 2 points or 1 rectangle? Why pass a float, a date, a string, da-da-da, when that's actually a person or an order or an employee? And even if you never put any member functions in these abstractions, just inventing the abstraction alone is going to make that signature much easier to get right. Sometimes I find functions take 10 parameters because they're really 3 functions. So break it out into the 3 functions. Now your rules are fighting each other. Because if I break it out into 3 functions, maybe I have an opportunity to be inconsistent, where someone somewhere else only calls 2 of the 3. So there's always a balance. And very often, taking the function and moving it in as a member function, even though the cool kids these days only use free functions, if you move it in as a member function, it doesn't need half of its parameters because they're just member variables and they're just there. So be aware of that also. I don't expect you to actually be able to read the code. Okay, I will show you a better version of it later in a bigger font. But this is arrow code. You can see the shape, right? It's going out, getting nested and nested and nested, and then it's coming back in. And the important thing of what this code actually does is here. way off to the side and really hard to spot, even when in a bigger font. And we're checking various things, and we're only going to proceed if these conditions are met. And so in the heart of all the loops, there's the thing we're really trying to do. Now imagine that you are a brand new intern and it is your job to add a fourth condition. If you do it first, if you do it before the X one, and even I'm having trouble reading this, if you do it before if X is less than limit, then you know you can put the else down at the very bottom and you'll probably get that right. But if you try to put it anywhere else, you're probably going to be unhappy. This is the same code. The only thing I did was I flipped the conditions. So the old code started if X is less than limit, we'll proceed. And this code starts if X is greater than or equal to limit. And then I moved up the error handling. And you can argue about the error handling and say that I shouldn't be returning a bool, I should return some more complex type, and you could be right. But this change right here is internal to the function and has no impact on calling code at all. Okay, so it's just very, very localized refactoring. Now the errors are with their problem. If I go back, you know, the error message about X being too large is the last thing on the slide. Right? And the error for the second test is the second last thing, and so on. Now here, each error is with its own check, so it's very easy to make sure that you're doing that part right. And of course, it's really simple to put another test in, either first, second, last, whatever, it doesn't matter. You're not going to mess it up. And the good stuff stands out. It's at the margin instead of being indented 20 spaces or so across the screen. So that's a very common pattern. The function did something, and then you're like, oh, we should only do it if whatever. So you add the if. And then you add another if, and then you add another if, and your good stuff was moving and moving and moving. And simply flipping the conditions around and saying we don't need an else because we would have returned if we had gone into that if. I have a bigger font, I have a shorter function, I have a better story. If I want to, I can take all those ifs and stuff them into something called check preconditions. And even more tell a story and be obvious. This is a trick I learned from James McNella's Const all the things. So we're not just talking about being const correct. That's a valid and useful thing to do. But we're talking about just slamming const on everything and then building and see if you get compile errors. Okay? You got a header file that's got a bunch of member functions. They're all const member functions. Yep, even the one called update total. Just const them all. And then go in the implementation file, put the const in, build, oh, update total, change the total, no problem, take it off. But you leave it behind, right, on the places where it could go. And local member variables. Got some int x equals 472. Try int const x equals 472. See if it actually changes further down the file. And it just reduces the moving parts. Now I know that although there are 10 variables in this block of code, only 2 of them, vary, and the others are really more like constants than like variables. And that means as I'm reading the code, there's less things I have to keep in my head to watch out for. Leave them behind if you want. They'll be that same kind of marker for the person after you. Now, it doesn't work well without params, or maybe it works great without params. You see, when you try to reason instead of just slamming const on everything and trying to build it, you see some foo at a, comma b, comma c. You don't know if a or b or c are left unchanged by that call. You have to go look at foo and see if it takes the parameters by ref, right? But if you const them, call the function, and it won't compile, then you're like, oh, this is being taken by non-const ref. I just learned something. So that's good. And you may learn that you don't like out params because they're not expressive, because you don't realize that it was changing its parameters. And you may decide to go change that function so that it returns something better, like a struct that you wrote yourself. Abstraction is always your friend. I mentioned our standard is a moving target. And I've been getting paid to program since 1979. I don't remember the exact moment I started C++, but I decided it was 1987, so I'm past the 30-year mark now. And I've been through the standard doesn't move phase, and now we're in the standard moves phase, and this is better, okay? Do not wish for the standard doesn't move. This is better, but you have to keep up with it. I did a guidelines talk at CPPCon where I talked about why you shouldn't do a const cast and how you could mark your member variables mutable. And the #1 response on Twitter, I got it from multiple people, was like, that mutable thing looks kind of interesting. I should check that out. Is that like a C++ 14 thing? When did that show up? People, I have a child who lives 12 time zones away from me because he's doing a PhD because he's an adult, and he is younger than mutable. You got to know your standard. Ranged fors, more expressive than regular fors. Deleted constructors instead of private constructors because it expresses your intent to the people who are reading your code. Right? These are things that we have gained this century. It would be good to use them. Non-static member initializers, which I started accidentally using because I have a C# experience as well, and my fingers typed it and then it worked, and I'm like, wait, what? But they're fantastic because you don't worry that different constructors will initialize differently. And the standard library. People don't like using the standard library. Hands up if you love it. See, that's what, a quarter? I love it. What's not to love about free tested working code that someone else documented? I know, it's got templates in it. Ew. We're doing a lot of work around making templatey things look less templatey, like class template arget deduction and things like that, so you don't ever have to type an angle bracket in order to successfully use a template. It was a big deal. And adding lambdas was what unlocked the library for me. Okay, because I didn't like function pointers. I just found you on function pointers, and I'm happy with the lambda. But the library is there, and when you start looking at what it has, you're going to be amazed. Okay, it's got amazing things in it. Some of them have been there, like mutable, for decades. All you got to do is know about them. See, here's the deal. When you're writing code, you are communicating with humans. It doesn't feel that way because you're typing to the compiler and you're calling the compiler some names while you're doing it, but you're really communicating with future you, current teammates, future takes over from you, and communicating in a lot of ways, not just when they're debugging your code, but maybe when they're copying your code to use as a starting point for their code. It's all communication, and you're leaving behind code that has something to say. And I want you to set up, this is a phrase I learned from Rico Mariani, the pit of success. The pit of success is the idea that if somebody does the most obvious, easy, no effort, not even trying thing, they will succeed. You set it up for them that way, they will do well. As you can imagine, it's not a beginner technique to leave behind a pit of success, but if you can do it, you are a good person. And you control the defaults that you leave for the people after you or literally by your side as you're typing. If you leave behind a place where there's these three things and you have to remember to change all three of them in the future, that's crummy. If you leave behind a single place that only needs to be changed in one place, you've left behind a pit of success. They're not going to get it wrong. They're going to change it, and it is going to be changed, and we're all going to live happily ever after. If you write good RAII, sensible destructors that clean up nicely, then whether the people are using exceptions now or not, they're not going to have misery when they start to. They don't have to remember to clean up. They're not going to get the weird intermittent bug because they forgot to clean up some paths. If you're const correct, anyone like playing Chase the Const? No one, right? So just be const correct today. Whoever calls you will thank you later. And give everything good names and keep your functions short, because this is a matter of setting those defaults for how the people after you are going to behave. I know the rules fight each other. I know that everything you do to make code simple can also make it more complicated. Right? Abstraction is your friend until you're over-abstracted, until you're over-indirected, until what you really do is completely hidden because it's 6 layers deep to get to the actual work. That's why all rules are vague. That's why the rules say a lot, or not many, or usually. And this isn't something weird about C++ or about software development. This is a law about everything. Have you ever taught someone to drive? How fast should you drive? Come on, simple question. What's the answer? Right? There's no answer. I mean, even you can start with simple answers like the speed limit, or like, oh, there's a car in front of you driving 10 less than the speed limit, you just ran into the back of it. Oh, okay, the speed limit or the traffic around you, whichever is less. Oh, a dog just ran out on the road. Oh, right, okay, yes, well, okay, put in the thing about braking for hazards. Okay, now we just went around a 90-degree corner, only you only went around 70 or so degrees of it, you know? What speed should you drive? No simple answer. What lane should you be in? No simple answer. I'm a new grandparent. The baby's crying. What do you do about that? No simple answer. And this is true for C++ questions. Should you use exceptions? How long should a function be? Are overloads confusing? It's just no simple answers. You have to use your judgment. You have to say, if I do it this way versus that way, which is more expressive? Which tells the story? Which explains itself to the people who come after me? You're not arbitrarily enforcing rules. No function shall be more than 25 lines long. Terrible rule. And you have to know what we all have to draw on. You have to be able to recognize and say, this loop starts at the beginning, goes to the end, and only ever increments one element at a time. I recognize that. We have a thing for that. It's called arranged for. Or it's called find if, or it's called accumulate, right? You can be able to recognize those things. Sean Parent did a talk in 2013, which was a life-changing talk for me, but which included the hilarious line. He's got like an entire page of code on the screen, the loop. And he's been explaining something about how Photoshop works. And then he says, well, this is obviously a rotate. And I went like, what? I thought rotate was the most useless function in the whole of accumulate until he showed me that if you don't go from begin to end, rotate is actually insanely useful and exactly what you want in a huge variety of cases. So if you learn what a rotate is, and you can play the this is obviously a rotate game, people will be impressed. Right? You can say, I'm worried that we're going to forget to call cleanup. Shouldn't a destructor be doing this? I'm pretty sure we're not the first people to ever need a stack or a JSON parser. Hands up if someone on your team has gone off for the weekend to write a JSON parser. Look at the hands, right? Oh my Lord. Or logging or getting stuff over HTTP or whatever. Like, yes, you're the first people who ever needed to log anything in your application. You should totally write the library for that. But it gets harder, okay? What does everybody know? You know what accumulate is or what rotate is, but will your team, when they're reading this code, have you made it more readable or do they not know? So you want to replace your complicated things, yes, with idioms, but they have to be familiar idioms. They have to be well-known library things. They have to be appropriate abstractions. You can't leave out needed capabilities. This isn't about let's leave off the error checking to keep it simpler, right? You can't hide what this thing does. I loved when the 7 pages main engine loop collapsed down to less than a page because it showed what it did. It now became obvious what that loop was, whereas before it had been buried in housekeeping. But don't go too far the other way and bury your intent in layers of factories and injectors and adapters and all that, you know? And don't slam in the simple change now that makes future changes much harder. There's a border. On the one side of the border is, I skipped a bunch of stuff to keep it simple. And on the other side is what I'm advocating for, this genuinely elegant simplicity. So then you have to not only be sure that you're on the good side of the border, but you have to be brave enough to stand up for it. Because I'll tell you, the first time somebody outside the team saw that much shorter engine loop, they said, is that all you did? It's like, what? Like you finally understand your own loop and you think I didn't do much? Right? If you have a lines of code per day mentality, there may be people out there who just want to keep typing a lot of lines of code and who want to create that Baroque wooden sculpture and say, look how smart I am. So being able to stand up for something that a 5-year-old could read is actually harder than you might think. Of course, you want your code to be as simple as possible, but no simpler. You know, I learned from Phil Nash that Einstein didn't say that. He actually said something much more long and complicated, and someone else simplified it. But it's easy to stick a 42 or a 60 or a 100 into your code. It's simple, right? But it's not. right? Because in the future, nobody knows what the heck that is. So setting up some const variable, adding an enum if there's a bunch of them, switching to chrono if it's about minutes and seconds, that's more work now. But in terms of leaving behind expressive, transparent, readable goodness, it's actually the right way. Throwing it into a global, because you don't want to deal with the chain of calls all the way to where it's needed, simpler now, not true simplicity, right? Watch out for people who say, I just. Usually the word just in a sentence tells you that it's the I left it out to keep it simple kind of simplicity. So I want you to take the time to write that shorter letter. And I want you to be able to be brave about, yep, it's not simple, didn't think it through. It's simple, brilliant, and I'm proud of it. I know my way around what C++ is today, and I'm confident that everybody else involved will too. People sometimes worry, if anybody can read my code, what role do I have? Are you kidding? Your role is to keep writing code like that all over this company for the rest of your life and never leave, okay? Don't ever worry that if your code is understandable that you don't have job security. I want your code to represent you when you're not there and to reflect just how far you have come from being a beginner. So to be specific, you need to learn, which means you're in the right place, right? What's happening in the language, what's happening in the library, what idioms are people using? Who's heard of I, sometimes another I, and then either L or E, L or F, E? Immediately invoked, initializing, lambda or function expressions. I know, so weird. It's weird enough if you don't give the variance on it, like 4 people. This is where you have a variable you'd like to make const, but you need some complicated initialization, bunch of ifs, bunch of loops, blah, blah, blah. So you can call a function called like init x, and then you can say int const x equals init x at whatever. People resist that, partly because they don't know what parameters to pass to init x. There's subtle bug introductions where like, oh, I'm passing that by reference, but I should have passed it by value or who knows what. So if you stick it into a lambda with a capture, you can preserve the old behavior completely, as long as you immediately invoke the lambda by putting a pair of parentheses after the final brace bracket. Very missable pair of parentheses, but if you do this, you can then leave x const after this tricky initialization. This is a really new idiom. I started hearing about it maybe a year ago. I might be late to the party. But the point is, has your team heard of it? Will your team spot those parentheses on the end of the line? Will this line of code be truly expressive? And the answer may be different today than in 5 years, right? So you have to stay on top of what's going on. You have to read other people's code because that's the only way you're going to learn what makes code readable and not readable. Read lots of bad examples too. And you have to care that the code you're leaving behind is setting up that pit of success for everyone else. And try testing things. If you think 2 things have a performance difference, prove it to me with the optimizer on, right? If you think that one particular way of writing something is more readable than another, try showing it to sets of people and asking them what they think it does. Don't rely on assumptions or just even randomly something I told you or someone else. And finally, remember that writing code is communicating, but that you can also communicate above and beyond the code. So you can tell somebody, say in a code review, I think arranged for would be a better choice here because, and then give your reasons, okay? Or I don't think you should be using the immediately invoked initializing lambda expression because it's too easy to miss those parentheses at the end, and I think I'd rather see you call a function called initx here. But communicate. And if you do those things, your code will get simpler, your code will get better, you will get happier, which is a good thing. It's very definitely not just for beginners, but I want you to aspire to that and to work towards that. Thank you. I don't know if I have time for questions because I started late. We're going into the break, but you're welcome to come up and talk to me one-on-one, and I'll answer anything you have.
Last example.